everyone, and welcome to this week's live streaming open Q&A. So we've just started our live streaming in Unreal Engine stream series, and during this Discord session and YouTube stream, we will be exploring different workflows involving Spout within Unreal Engine. So we will be using the Off-World Live media production toolkit, and alongside that, we'll be looking at specifically using TouchDesigner to create real-time interactions with Unreal Engine via Spout. So previously, we have just started another Spout kind of masterclass around understanding what it is good for. And so another introduction of that to understand what Spout is that it is a very neat solution that allows two or more graphics and media programs running on the same GPU to share the same video texture. And so it means that you don't have to re-encode the video in order to share it between different software. And what's really, really great about Spout, as I use it all the time for all my workflows, is that there is no latency, compression, or CPU overhead. And because it's the same video texture that's being used by different software, you can easily send it over from Unreal to TouchDesigner, from TouchDesigner to Resolume, and Resolume back to Unreal Engine, just as an example. And of course, lots of new media artists and content creators have already been using Spout. I remember using Spout as part of my student project many years ago on kind of streaming from Unity to, for example, an LED wall somewhere. It's a really neat and great solution that allows us to kind of stream high quality and high resolution video feeds. It's also lossless, so we're making sure that we have great visual quality and great performance. Unlike NDI that has kind of higher compression and maybe a bit of latency, maybe you get a few seconds here and there, Spout really doesn't have that issue. However, the only downside to that is that it's limited to a single GPU at the moment, so we can't use it to share between machines really. But for today, we'll be focusing on 3 different workflows. As you've seen from the teaser, you might have seen that we've kind of developed different workflows to be used between TouchDesigner and Unreal Engine, and I'll be introducing these workflows very, very soon. So I got really inspired from kind of working on this stream because I noticed Spout is making a comeback, and I was like, Spout's been around for so long. It's really interesting to see how people are still using it. So the many workflows we can use Spout for within TouchDesigner and sending that to Unreal Engine is that we can potentially do a few different things. We can send a texture from TouchDesigner to Unreal. This could be any texture, logo, kind of moving image, and then we can use this texture and sample it with Niagara particles. We can also stream different things. So if you are kind of quite familiar with TouchDesigner, you will know that you can turn a top to a chop, to a dat, back to a top somewhere, and this kind of fluidity between different types of operators allows us to kind of stream different data as textures. And so you can, if you're kind of familiar with this kind of like new media kind of technique, we're always kind of trying to send transform positions as RGB values, and so this can be easily done as a part of this kind of data streaming via textures. So something I'll be covering today is also using body tracking, geometry, sending over geometry position, scale, and color using Spout. We can also create, if you have a Kinect at home, you can also create point cloud visualizations within TouchDesigner, as you already know. But what if we want to kind of have that housed within TouchDesigner, but send that to Unreal, and then have Unreal mirror that point cloud, the point cloud in a Niagara system? That can also easily be done with a kind of texture. With a texture that you share between two programs, you then get to have two types of point cloud, which is really interesting. And obviously, we can also stream instancing data from TouchDesigner. So this came from a masterclass from Function Store a couple of years ago, and I'll be reusing this workflow as it's taught me a lot of different techniques. And I'll be covering how we can instance. For example, we're instancing geometry to a grid, perhaps, and then we're using this kind of like unique instancing ID or number to change different positions within a Niagara system. So it's I would say it's pretty advanced, but very fun. And finally, there's another final use case that I've seen on Instagram stories a lot, actually, which is that you can always stream your Unreal Engine game view or video or kind of camera capture into Stable Diffusion that's housed inside TouchDesigner. And finally, before I jump into the kind of demo workflow, I just want to remind you that a couple of years ago we had this masterclass that's led by Function Store. In this masterclass, we were taught how to kind of use textures as a kind of like container to house different information like transform, position, scale, rotation, and color, which is really, really interesting. So this is one workflow. The first workflow we'll be covering today. The second workflow we'll be covering is streaming tracking data as textures via Spout. And so apart from so this current thumbnail, as you can see here, is a media pipe kind of TouchDesigner template. You can also use the kind of embedded NVIDIA pose tracking node for this, but basically, essentially, we're using our webcam. We'll be using our webcam and streaming and using MediaPipe to track, for example, the position of my nose, and then you can kind of stream the position of your nose as a texture to Unreal Engine and have Unreal read this data. Once Unreal reads this data, it could potentially, you can see this janky version of it, but I'm using pose tracking and I'm actually sending all of the kind of pose transforms as a texture, and then I'm using that in an animation blueprint in this kind of old stream. This stream probably happened a couple months ago that I first started exploring this workflow. And our third workflow today is to look at texture sampling. Texture sampling with texture sampling with Niagara systems. So let me have a quick look. Texture sampling with Niagara systems. And so here is, I believe this is Immersive HQ, but this is a great kind of tutorial from them exploring how we can sample a texture and use this texture in a Niagara system. And then finally, as I've mentioned, using Connect, or you can use different kind of like image to depth kind of AI models within TouchDesigner now to kind of get depth data. And then from this is an example from Function Store again. Using a Connect, we get point cloud, and then we use we send textures into Unreal and then use Niagara systems to kind of instance the kind of like the individual points back. And so this is such an exciting workflow that I think more people should be using. You can think of TouchDesigner as your controller, um, and Unreal Engine as your visualizer for this type of workflow. So today, again, just to recap, we'll be learning how to live stream textures from TouchDesigner to Unreal for 3 different types of workflows. First one is to instance geometry data from TouchDesigner to Unreal's Niagara systems. Secondly, we'll be streaming tracking data as textures via Spout. And third, we'll be exploring how we could use point clouds in Unreal Engine via Spout texture sampling. So this is a simplified version of point clouds without the need of a Kinect camera. And so when I first visited this masterclass a couple weeks ago, I noticed a lot of people are also struggling to follow the whole way because it is such an advanced workflow and it does come with quite a lot of steps. And luckily for today's tutorial, I've basically gone through the whole process and annotated everything. So I'm going to open up my project files now. I've created the particle instance TouchDesigner template, and I've basically commented on everything that you'll need to know and everything I've set within TouchDesigner. And similarly in Unreal Engine, my Niagara system is also fully commented. So once I upload these assets onto Google Drive, I will paste a link in the description down below. Feel free to follow through, and you should be able to use this template and also use the Niagara system directly. So I'm just going to have a quick look. Over here. So this is the template I've created for today. I'm just going to briefly explain what this TouchDesigner file is doing. So today we'll be working on our first workflow, which is instancing geometry from TouchDesigner to Unreal Engine, and we'll be kind of recreating this through a Niagara system. And so this project template follows the masterclass stream with function store, and I've pasted the link over here. What we will be streaming is geometry position, rotation, scale, and color via texture streaming through Spout. And so the first thing I have done is to create a box geometry. And for those of you who are new to TouchDesigner, to create a geometry that you can render, you'll need essentially 3 things. So first, we'll need the geometry. Secondly, we'll need the camera, and then we'll need a light. And with once you have these 3 components in the comp, so camera, geometry, and light, you can then go to top and click on render. Once you click on render, all these will be automatically linked to the render node. So what I've done here is basically I've started with a SOP, and the SOP creates, I need to create a box from the SOP, and so I use the box as my first operator, as the source of my geometry. So here you can see that this is a box, and I've linked it to geometry so that my geometry is basically box. Hope that's clear. So then with these 5 nodes all together, we've basically created a box geometry. So obviously your one won't look like this moving box just yet, but you should have a box within the geometry and it is rendering to a top like so. And then following also the function store workflow, I've created a grid. And so a grid is another form of SOP. So a SOP is over here. We'll need to create a grid. So click on grid over here. We're using this grid, and I'm currently using 10 by 10. So I'm going to just quickly edit this. So I'm using a 10 by 10 grid, hoping to instance this box. So using a 10 by 10 grid, I would love to have a box on each of these intersections. So box, 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 so on and so forth. So I should have like, so I should use this grid as the kind of like outline for where my box should instance. And instancing is basically, I think you can think of it as like a spawning system. You're spawning boxes along the lines of this grid. And I've here added a noise, which allows us to see the grid. So I'm making the grid solid now, but I can also click on this little right bottom corner viewer active button and then press W at the same time to see this grid. So I'm basically just using another SOP operator called noise and connected them, and then I'll be adding noise to this grid to create this flowy texture. And here I have done something special, which is converting this noised grid to a chop. So chops are channel operators, I believe, and it is seeing our data through channels. So currently we have 3 channels. We have TX, TY, TZ. And as you can see here, the rows are 100. The rows are, columns are 100 on this chop because we have 10 by 10 rows and columns as a grid. And so it's basically going through the grid, which is 100 in total, 10 times 10, and then telling us where each point is in the x-axis, y-axis, and z-axis. So this is all the kind of point transform data for each point of the grid. Hope that makes sense. And with that, I'm using this. I basically have this kind of chop as how I want my geometry to move. And so now we have a chop over here, and I want to use the grid to instance the box. So with that, we first need to change this chop to a texture. And once we have this texture, so it's chop to top texture operators, and we're using a top to house all the transform data of each box to a texture like so. So I'm using chop to top. And the reason why it looks the way it looks is because all the XYZ data is basically used as RGB data for each of these pixels. So here it's quite like seamlessly converted into each pixel. So the pixel color is actually derived from TX, TY, TZ. And with that, we basically have the kind of positions of where we want the boxes to be instanced. And so this is a really important operator for us to get the position of where the boxes should instance to. And so this position node is essentially like pulling out of the chop to top node and clicking on a null. So this is basically an empty, and I've just renamed it into position. From this texture, we basically have something we can definitely use. I went into geometry to turn on instancing, and I've basically, because as mentioned, the t, x, t, y, t, z are position values, and that are turned into RGB values. And so all we need to do is drag this node position into here, and then type RGB to translate X, Y, Z. Here we basically are using the texture value to instance the box. Hope that makes sense. And really we want to use this for scale and rotation and color of our boxes as well. So once you have instancing on and position RGB, you'll see that the boxes have started populating. And because there's noise as well, it's basically always moving. So I've added a math node between chop to top and position. This math node is really interesting. So if you look at the preview in my background, I can kind of change the multiply slider. You can see the positions of my boxes will move. And so you can see that we're using the texture operator as a source for how the boxes should instance. And this is a really fun way to use textures to drive your box animations, let's say. So we already have a functional texture. We'll basically need to recreate something like this for scale and rotation as well as color. So here we're just using a kind of like pretty common technique. This common technique is called noise. So adding noise to the chop to top, which is the transform data of each box, we're making it into a different texture that kind of that is perhaps more blurry. And I've also used a little trick to feed in the kind of abs time dot seconds, which is the time we're using kind of the editor for, and to times 0.01 to make this a constantly moving texture. And I've applied this to the Z axis of the translate, so we can constantly move the texture in the Z axis. We're constantly translating this. And here I've also added a math node. And as you can see here, we can use this to zoom in and out of, scale the size of our boxes. And then I created a null to house the scale, and I've used the scale as the scale operator for my instance op. And so again, we put in the scale op, put in RGB for X, Y, Z respectively. Finally, we have rotation. I've basically done a copy and paste really, and added a noise. And again, you can see here, I've done the same thing, making sure the noise texture is animated. I use a little trick to use time to translate the texture. And I've added a null to house the rotation values. And again, fed into the geometry's rotation op and fed in RGB. And finally, you might also want to stream colors with your boxes and particle systems. So I've just used another noise texture and basically use this as a null directly. You might wonder where is the instance color op. It's basically in the second tab over here. So color op is at the bottom of your second tab. Here you'll find that you can enter the information color RGB. So this is the quickest way I've gone through Function Store's workflow, but let me open up Epic Games Launcher and show you how this project looks when I connect this TD system to my Unreal project. So I'm currently just using my 5.4. And I won't go into the Niagara system just yet, but I'm just going to show you how I can use TouchDesigner to drive particle systems within my environment. Just a second while this loads up. Great. Should be loading in a second. And again, I'll be uploading this template onto onto Google Drive and sending it to the kind of caption down below. We have a question. Ghost FX says, so like it reassembles. I think, yeah, so I think basically we're using this TD system to stream textures like that has information like position, scale, rotation, and color. And then we reassemble that in Unreal exactly. But one thing that the reason why we need to do that, or certain people would choose this workflow, is perhaps you're using TouchDesigner as your controller and you're using Unreal as maybe your visualizer or your output or for virtual production or for real-time performances, so on and so forth. Then we're assembling this pretty much real time with Niagara particles. So that's the kind of like technique we're using here. I find it's just so fun to play with, but it did take me some time to learn this workflow. Okay, so let me go back to a lit environment and coming back to ground level. So I think I've created the instancing system Niagara particles. And I need to make sure that my Spout receiver manager is on and receiving. Yep, that should be working. So I've just hit play simulate on my editor. So we have a bug here. I think it's an editor bug. It's nothing to do with the project. But as you can see here, if I split my screen side to side, you'll see that if I move my scale with this math operator, I'll be able to very quickly stream using just texture streaming. I'll be able to adjust the scale of my Niagara system. So this is like, honestly, one of the fastest communication you're going to get because we're actually streaming quite a lot of information. Transform, scale, rotation, color. They're all just 4 textures you can get without any latency. Like so. And I wonder if I can do the same thing with color. Well, color is most likely, but I can maybe do something fun, like just using the emboss Let me think of what's a cool top operator that we can play with. Maybe levels. Level. And easily change the color, brightness, gamma, contrast. And this is all just done like instantly. Super, super fun. And of course, so yeah, these templates will be up on Google Drive very, very soon. But for now, let me show you um, how I have used this template within a Niagara system. So first of all, to receive textures inside Unreal Engine, the first thing you'll need to do is make sure that you have the Off-World Live Media Production Toolkit. Here I've added a Spout Receiver Manager, as you can see here. And in my Spout Receiver Manager, I have currently got 5 receivers on. The first one is my position. So I've created each a render target called RT pos, RT rot for rotation, RT scale, and RT color. And the last one is just a one that we'll be using later, but for now you will need 4 render targets for this to work. So as you can see here, these are already streaming. These are tiny, tiny, tiny textures that we have been sending with TouchDesigner. And in order to send this, we just need to find the node siphon spout out to make sure that our pixel format is a 16-bit float RGBA. And I've also used nearest pixel for input smoothness and viewer smoothness to make sure that there aren't any like kind of interpolations between them. So they're quite clear cut, as you can see here. These textures are very small, so if I right click into info, they are 10 by 10. And the reason why they're 10 by 10, as I've explained before, is that the grid is also 10 by 10. So they are the exact same copy of like the information we have here, plus the math node, I would say. So we have a 10 by 10 kind of like 10 by 10 texture 2D streaming into Unreal, and we have 4 of these. Next, we will need to create a Niagara system. And what I've done here is to click on right click. I think perhaps you could also do the same and build this from scratch, but I have already done this for you, so you can use my asset. But I've right click and created a Niagara system, and I have added an empty emitter to my Niagara system, so it should be empty. And here I've basically included all the steps you'll need to recreate this Niagara system. So I'm going to walk through each one by one, but I think it might be just that easier for you to follow these tips and tricks on the right side. So the first thing you'll need to do is to click on Properties. In order to sample a texture for Niagara systems, you must use your sim target should be set to GPU compute sim. It will only work on the GPU sim for any texture sampling, so make sure to pick this one. We also have to do a few things. So first, I've kind of turned off interpolated spawning. We won't need that at all. We'll also need to make sure that the bounds mode is fixed. You might come into different errors if you didn't fix your bounds. So make sure to calculate bounds mode to fixed. Here, I've kind of set a random range that I've I think works for me, but minimum I've gone from -200 for all of them and maximum 200 for all the maximums. And finally, most importantly, we will need to use persistent IDs. The reason why we need persistent IDs is that for each incoming texture, we want to make sure that each pixel is responding to each pixel is responding to each box in the instance. And so this is really, really important that we need to require persistent IDs for this to work. Secondly, we will be going into emitter states. My settings, basically life cycle mode is self. My loop behavior once. My inactive response is complete, let particles finish, then kill emitter. And the loop duration is infinite. We're making sure that we only need to loop once, and we're infinitely looping this. And finally, in the initialized particle, I think it's this one, or particle state, sorry. Go to particle state first and make sure that we disable kill particles when lifetime has elapsed. This is to make sure that we don't destroy the particles, and we make sure the same count is retained. And it's very, very important that we retain that. Then we can start building off our Niagara system. All the base settings have been set. I've added a spawn burst instantaneous from here and created a user exposed variable called spawn count. So to create this variable, you will need to go to user expose and click plus. We need to create a variable that is of the type integer 32, so int 32. Once you click on it, you can name it spawn count. The spawn count is basically identical to the ID of each pixel. So spawn count is 10 by 10, so it's 100 essentially, and we can set that in the kind of once it's user exposed, it means that in Niagara component we can see it over here. So we need to set that manually, as the masterclass and function store says that this is the only way we can make sure that it's matching our textures. So once you've created the user exposed variable, you just need to drag and drop this into the spawn count. Next, in initialize particle, we will need to make sure that our position mode is direct set. So position mode direct set over here, meaning we don't need the particles to be positioned randomly. We want to directly set it from the textures we have access to. And finally, we've already done this. We then need to add a mesh renderer. And I've added a mesh renderer and kind of turned off the sprite renderer. We want boxes, not kind of textures, as our particles. So I've added a mesh renderer and pulled in a cube over here. I've also enabled material override materials, created a custom material that is super simple. It basically goes like, I typed particle color, can't type, particle color, and linked it to base color, just saved and applied to here. It basically uses the kind of color we're going to sample, and then we're going to use this as the material for the Niagara. So now basically everything is set, but the most important part is how we can link the textures and sample these textures. How we can sample these textures and use each pixel's information to drive Niagara. So first we have, you can see that these are the things you don't have as of yet. Sample texture spout position, sample texture spout scale, sample texture spout rotation. So the reason why you can't search for these in the particle update It's because these are custom modules. So I've created a custom module following the tutorial, which is a Scratch module. So a Scratch module is basically these little scripts inside your Niagara system, and they come with its input map and output map, a module. So whatever we kind of go in between, we create different kind of variables that we can access for Niagara system. So the first thing we need to do is I'm just going to go through this really quickly. But again, the whole goal of this custom script is to match corresponding pixel for each particle ID, meaning I want the texture, I already received the texture, but I want to use each pixel of the texture according to how these boxes are instanced. So for example, this pixel has the transform value of XYZ. I want to use this for the corresponding box in the Niagara system. So this is basically matching pixel to box in Niagara system. And the quick explanation to that is that we're sampling textures at specific UV location and making sure that it returns the correct color, because boxes were instanced at each intersection of the grid. So there's some math here that we need to do, because as I've mentioned, how instancing works is that we're instancing the box in these little corners. And in these corners, it's confusing what pixel kind of data it has in terms of RGB because it's on the edge. So we need to do a slight shift of moving everything to the center of each pixel. So let's say if this is 0, 0, 0, 1, 1, 1, 1, 0, something like that, then we need to find the middle of each pixel and sample the correct color and values from that position. So I feel like I can quickly go over this because this is already done for you, but I'm getting the texture sample, I'm getting the ID. Once I have the texture dimensions, I've broken the X and taken the index and convert index into 2D lookup. We're basically assembling a grid back together. So using the number of rows and columns to assemble a grid. So I'm getting the texture dimensions, which is size X, and then filling back up with the Y values. So we're sorting instance and particle ID back into a square pixel format like that grid. So we can use a 2D lookup node. Then we're basically getting the texture's dimensions, and we need to look at the middle of each pixel as mentioned, not the edge, not to get confusing RGB values. And we need to add that little half step to each of them. Then we have the sample texture 2D node that helps us sample the texture colors. And for each we will get sampled color and sampled UV. So it's simple enough, but kind of hard to explain kind of module. And here we can apply the Scratch module and then search for it in here. So I've done this for each texture, position, scale, rotation, color, and I've set them for their corresponding Niagara element. So I've set the particle's position using this render target position, and for the color that's sampled, I had to add a vector to the position, and then I have to make my texture back to a vector, which is what I've done. And I've just dragged one of the outputs of the Scratch module into here, and you can find this over here as well. And then similarly for scale rotation, I've done the same thing. For scale, we're basically updating the scale mesh size of each box. And then for rotation, we're updating the mesh orientation of each box. For color, we're just directly affecting the color of the particles. So now we've got something working like so. So I hope that's clear. That was quite a long description, I realize. So that was just one workflow where you can use Niagara systems with texture sampling from TouchDesigner. And we also get instance data as well, which is really, really cool. Okay, the second workflow I want to go through today is to stream tracking data as textures via Spout. So here you will see that one thing I've been working on previously, if you've seen our previous streams, I've been focusing a lot on pose tracking, which I think is really, really fun. So similarly today, I'm going to do the same. So I'm going to kill this box now, save and quit. I'm going to show you another template I've been working on, which is the media pipe TouchDesigner template. It's just loading up now. And now my media pipe is loading. You can see my face over here. I'm going to hide myself for a bit. So first of all, just to explain, I've mentioned two types of tracking kind of alternatives. The first one is media pipe, which is a Google kind of a Google model that allows you to track your face, hand, pose, object tracking, face detector, so on and so forth. What we can do with this is, if I just start cooking again, we'll start to load and like take it some time. Take some time to find my webcam for a while. Reset. There we go. So just again gonna hide myself for a bit. But as you can see here, I'm still speaking. I might have to use this for it to work. As you can see here, I'm moving my face and the face tracking is working just fine. And we also have hand tracking, so I'm moving my hands now. You can see the dots. See that I'm rotating my wrists. And pose tracking, which kind of marks different landmarks on my body. And you have the different positions of the dots. And if you kind of drag a null chop out of it, you'll see that when I'm moving left to right over now, over my webcam, and you can see that the different values are changing. So this is also tracking the XYZ values of each landmark. Like so. So these are just some kind of examples. Obviously it has object tracking, and all of these we can convert into textures that we send to Unreal. So previously what I've done is use the face tracking node and use a blend shape, pull out a blend shape chop and turn this into a chop to top so that we get a texture out of this. Today I might not do this tracking. Might not do face tracking. I might do just a pose tracking of where the nose is at. So I'm going to not detect facial landmarks, not detect objects. And hopefully this saves me some frame rate. I feel like this view is just a bit slower, but it's actually tracking all right. Everything, my FPS is quite high. So I'm just going to use pose tracking today to show you how I can send tracking data from MediaPipe just as an example. Or you can also use this chop, which is a pose tracking chop, body track chop that TouchDesigner has recently integrated into a chop, which is so useful, and use the kind of data from here as a texture. So just going to go for something really, really quick. I have pose tracking and different landmarks. And if you pull a null out of that, you'll see that these are all the different landmarks that you can track. I'm going to select one of the channels, and today I'm using the x-axis of my nose. So if I'm moving left to right, you'll see that my kind of the values of my x-axis are changing. This is just so I've just selected nose X as a channel, and I'm using this value to make my chop to top texture. And chop to top, I have used a data format of R, so just one channel with the data format R, which is red. And I'm making the more kind of the bigger the value on the x-axis, the more red this texture becomes. So I'm using this siphon spout out to send to Unreal. So this is what I'm going to do now. I'm going to go back to Unreal. I made a little blueprint, which is just which is called a BP render target reader. So I'm going to check what this. I'm going to make this nose tracking as my spout sender. And on my receiver, I will add nose tracking and create a new render target called RT nose. Now I have a very perfect nose tracking render target that I will be hopefully using this to track my to drive different interactions within my level. So I've created an empty actor blueprint called RT2 pause X, which during event tick, I can read a render target pixel, and I'm going to read the RT nose render target. I'm using XY position of 1, and which is the kind of basically the pixel value, pixel number, or like where I should read the render target, and returning value. If the red value, we're using the red value in bytes to set the world location of this blueprint, and we'll be teleporting this plane. So I believe if I start moving, it should move. Let me see. Yay, so it is working. You can see my face moving left to right, and this should also be moving left to right. So I'm going to change this back to the nose so you can see. So I've just assigned a material with render target, and the more right I lean, the more red the texture becomes. Vice versa, if I move left, the more dark this texture becomes, and it's also teleporting my plane perfectly in sync with no latency at all. When I've been doing this via OSC, which is something called Open Sound Control, it's a protocol for sending data between different programs. It's always got this weird kind of memory issue because I'm not a programmer. I don't know how to fix within Unreal Engine. But this solves everything because I'm always containing my data in a texture format and I know about dimensions and pixels enough to work around how big my stream is and how heavy this is. So this is just one extremely quick way to send tracking data. So that's our second workflow. And finally, I'm going to show you our third workflow, which is texture sampling. So I'm using the most basic texture to Spout TouchDesigner workflow, which is dragging in an image, sending that via Spout. And we will be using a Niagara system again to sample this render target into something amazing. So I will be hiding. I think I'll just hide this render target reader, and I dragged in my render target sample Niagara system. And here on my left side, you will see our off-world logo and Spout out. This is how simple it's going to be. On the right side, we have my render target sample Niagara system, which is creating, I mean, sadly, sadly, the dimensions are wrong, but here, as you can see, it's a beautiful particle systems that's instancing based on how the texture looks. So again, if I were to kind of add some dynamic animations to it, what should I use? Something I can skew and displace my image really quickly. What does this mean? Calculates a flow simulation. Nah. I need something like is there something like a twist or transform? Maybe just a transform. And we'll be rotate. We can do some rotation, that's fine. We can use something like a chop, which always has L O, and we use this to transform something. I don't know. Depth of convolve. Corner pin. Let me see what this does. I've never, this is cool. So we'll just use this data, export chop reference. So now we have a kind of displacing system, and of course of course, our particle system is responding to it really quickly. And again, if you click on this, you'll be able to see how kind of amazing this texture, this kind of particle system is, because it is actually made of a grid of all particles. And it's not just a texture. And I just feel like that's so much better than streaming a static texture. So with this workflow, I'm trying to recreate point clouds through just a simple texture. Obviously, you can send so much more like depth data and stuff like that, but we're just using simple texture, simple images like these to turn into this amazing system. So if I click on this Niagara system again and reset, you'll see that all the kind of dots are populating. And we can add different things. I'm just going to show you what this render target sample is. So it's very simple. Again, we're using GPU, compute sim, fixed bounds, minus 2000 for min, 2000 max, requires persistent ID, self, infinite, and system. Let me see what does once do. Maybe that's fine. We use our spawn rate kind of changes how many particles there are and how long it takes to kind of populate. So you can have this up or down, that's all fine. And we need to make sure the kind of mesh attributes are uniform, or sprite is uniform. We're using a sprite rendering for now, and we're using direct set as the position again, so very similar. And then next, what we need to do is to set the particles from a random range vector 2D. And we also created a little scratch module. And this scratch module takes the particle UV, break it into X, Y, and then make position so we know like where to map this. And particle state, we don't kill particles again. And here we've got sample texture, which really just comes from a Niagara setting. Click on sample texture, drag in your render target, so we can quickly drag this in with all the different textures I have. And you'll see that it's creating different texture, different things like that. This is really cool. This comes with alpha as well. So this is where you can get creative with point clouds. Something like that. So of course we want to go back to OBS, RT OBS, which is our logo. And that's pretty much it. So this is one way to create point cloud systems from just a single texture. Again, we won't be covering more, but I just want to let you know that there are so many ways. You can also get depth data like Connect from TouchDesigner and so on and so forth. And so with just a simple texture, you're able to create a point cloud, which is a great start, but there's so much more you can do. So with that, I just want to quickly wrap up and to show you what we've learned today. We've gone through 3 workflows: instancing geometry data, streaming tracking data, and creating point clouds with a simple texture. So that's it for today. Thank you so much for tuning in. I hope you've learned a lot, and next week we'll be going into something around kind of streaming your game view into Stable Diffusion inside TouchDesigner. So yeah, thanks for tuning in, and goodbye.